to this demo of a custom CNN model that I've built just for fun. What this model has been trained on is I've trained it to look at images of a person and identify who that person is, and in that case it has only been trained on the images of my daughters Niyati and Vanshika. It's a face detection, face recognition model. Quick walkthrough of the code. What we're going to do here is we're going to import TensorFlow Keras library, and then the model has already been trained and saved to the disk. So what I'm going to do in this notebook is I'm going to reload the trained model and then essentially pass the location of the directory where the images are. Quick look at the directory structure. So training set and test set were the images that were used to train the model, but what we are going to look at today is that the trained model will be given the location of this guest directory, and this has images which the model has not seen, and it will be tasked to look at this image and predict who the person in the image is, right? So with that as the intent, let's do a quick 30 seconds walkthrough of the code as well. So we'll give the location of the guest directory. The model will loop through all the images. Once it has loaded an image from the directory, it will show it on the screen so that we can interpret the test results as well, and then it will create a MTCNN based face detector that will identify the bounding box, the coordinates of the faces, and will pass it to the extract face function. The extract face function is going to take those coordinates and crop out the image and save it as a new image in a temp directory and show it on the screen as well, and then pass it to the predict person function. The predict person function is going to then take that image and first make sure that it is loaded as a 256 by 256, and that is because that's the size on which the model has been trained. So once that is done, we'll do a little bit of feature scaling, normalization, etc., and then we'll ask the model to predict who the person is. And the person would be Vanshika if the score is more than 0.5. Otherwise the model will say the person is Niyati. This is essentially a sigmoid function that we have used here since we are talking about binary classification, right? So enough about the code. Let's go ahead and rerun the code. We'll restart the kernel and let me run it. So we are importing the TensorFlow 2.6.0. And then now let's run the code. So first image it is loaded is of Niyati. Now the face detector will come in and it will take the face and the model predicted it as Niyati. So first one is correct. The second one that is loaded is image of Vanshika. It took the face from the image and correctly predicted it as Vanshika. The third one it has loaded again Niyati. It's correct. This one is Vanshika, correct again. This one is Niyati, so correct again. So model is doing a fairly decent job. Again Niyati, this one is also correct, and this one was a tricky one, and yes, it got it right as well. And this one is again Vanshika, this one is Vanshika, this one is Niyati, it got it right again. This one is Vanshika. So the model is performing really well. Looking at this one is Vanshika, and this one is, it has got it wrong. So out of the 10 odd images, it got 9 of them correct, which is a fairly decent accuracy score given that I've trained this only on, let's say, a handful of images. So that's the demo. Thanks so much for your time. Thank you.